Hello everyone. So today we are back with another chapter of our grade 8. The name of the chapter, students, that is electricity, magnetic and heating effects. Basically this chapter will be related to electricity, that what are the effects of electricity, and to be precise we will be learning about magnetic effects and heating effects in this particular chapter. Students, this is very important chapter as per your exam point of view, as when you were in grade 7th you must have learned electricity circuits and their components. As now you are in grade 8, you will be learning electricity, magnetic and heating effects. Similarly, when you will be promoted to your grade 10th, there will be one more chapter named as magnetic effects of electric current. In grade 12th, one more chapter magnetism and matter, and magnetic effects of electric current and moving charge will come. Now, why these chapters are important? Because you can see here that in JEE exam or in NEET exam and NEET, you can see here that 4 to 5 questions. That means 4.66% of questions come from the same topic. So that is why this is very important chapter as per your exam point of view. Let's see that what we are going to learn. So this is your table of content. You can see here we will be starting our chapter by learning about basic introduction to electricity, that what is electricity, sources of electricity, electric current, flow of electric current in wire, and all of the topics which are mentioned here. And we will end our chapter by learning about electrolysis of water, electrolysis of copper sulfate, and the process of electroplating. So let's start our lecture. Let's learn about electricity. So basically, what is electricity? First point here, electricity is a form of energy, right? We have learned about various forms. If we talk about sunlight, so that is what sunlight, it is also a form of energy. Light is a form of energy. If we talk about sound, so sound is also a form of energy. So similarly, electricity, that is also one more form of energy. And electricity, it is integrated part of our life nowadays, because we cannot imagine our life without electricity. All of the electrical appliances, let's say that you are able to view me. So you are able to view me because of what? Electricity. Because if you are using laptop, if you are using television, so electricity must be supplied to them. If you are watching me on the mobile phone, so then also we have to charge those mobile phones. So again, electricity is used for that purpose. So this is the point here, that we use electricity for many purposes to make our life easier. Now there are sources of electricity, that part we have to talk about. So first of all, same part is written, we use electricity to operate pumps that lift water from the wells, that means for borewell purpose. Apart from that, electricity make it possible to light our homes, road, offices, markets and factories even after the sunset as well. So that is the point here. Now the question arises that from where we can get electricity and how much amount of electricity we can get from there. So on the basis of that, this is the topic named as sources of electricity. There are two sources of electricity, students. The first one, that is power station, and the second one, I am writing it here, that is going to be a battery. Let's say, students, that we want large amount of electricity to light up whole hospital, whole community halls, whole of, you can say, bigger malls and schools like that. So for that purpose, we will be requiring much more amount of electricity. And if we want more amount of electricity, so the source which we use, that is going to be your power station. Because in power station, large amount of electricity is being produced and circulated all over the areas. So that is the first part and the first source of electricity, which is your power station. Same part is written, it is the main source of electricity. Why? Because all of the needs of electricity, that is being fulfilled with the help of your which part? Power station. Next part, students, next part is it produces and supplies a huge amount of electricity, as I have already explained you. So that is the point here. And how this electricity reaches our home. So you can see here that there will be long wires and poles which will be present near the roadside. And what they do is they bring electricity from one of the section to another section accordingly. The second way, as I have explained you, batteries, or we can say electric cells. Let's say that we want very small amount of electricity, right? So from where we can get it? We can get it from the help of electric cells, or you can say batteries. So same part is written, it produces a small amount of electricity. That means if I want small amount, little bit of electricity, so I can get it with the help of cells or batteries, which you can see here. The second point is, it is portable and safe. What is meaning of word portable? Portable simply means port. What is meaning of port? Port means we can take something from one to another place, right? So similarly, you can understand the concept of portable. That portable means that we can take it with us. I can keep a cell or a battery in my pocket and I can travel with it. So it is portable because I can take it from one place to another. And second part, as I am able to keep it in my pocket, that means it is safer to keep as well. So that is all about your second part, that is electric cells. Now the next part is, students, the main topic of our today's class, that is electric current. What is electric current? Let's try to understand it with the help of an example. Let's suppose, students, that we have a wire here, or you can say any of the material. Now this wire, students, it will have numerous amount of electrons, or you can say numerous amount of charges present in it. And when these charges, when they will start to flow in one of the direction, then what we will say, that electricity or electric current is generated over there. So same part is written here, that what is electric current? Electric current, it is simply defined as the flow of electric charges called electrons in the conductor, in the metal wire. That means in any of the conductor, if there are some electrons, and if those electrons are flowing, so electric current, you will get it from there. Now, one more way to define it is the amount of electric charge passing through a conductor in unit time. That is one more way to define electric current. Next part is, students, as you can see here from the second definition. So first of all, see here the symbol which we use for denotion of our current, that is capital I. Charges, they are represented by capital Q, and time, it is represented by small t. So if I want to write the formula for our electric current, our formula will be I is equals to Q by T. This is our formula to find electric current. If we know that how much amount of charges are flowing in how much amount of time, so we can find the how much amount of electricity is produced or flowing from that particular conductor. Same part is written here, that if the charge of Q coulombs, right, that means charge is denoted by capital Q and the unit is coulombs, obviously for our charge, so that is written, flows through a conductor in t seconds of time. So that means time, we are representing it by small t. So then the magnitude of electric current, capital I, current is represented by capital I, flowing through it is given by I is equals to Q by T, right? Let's suppose over here charges is not given to us and number of electrons is given to us. So first of all, we will have to find the amount of charge, and the formula which we use for that purpose, it is Q equals to Ne, where N stands for number of electrons. As you can see here, Q equals to Ne, and what is N? N is number of electrons, and Q is what? That is your charge, and E is what? E is charge on one electron. And how much charge is present on one electron? So that is minus 1.6 into 10 to the power minus 19 coulomb. So that will be your charge on one electron. I am writing it here as well, 1.6 into 10 to the power minus 19 coulomb. That is charge on one electron. And if I am writing minus over here, this means I am talking about electron. If I am going to write, let's say, plus over here, this simply means that I am talking about charge on proton. One more point here, if someone asks you that how much electrons are present in 1 coulomb of charge, let's say I know the value, that charge is how much? 1 coulomb. But if someone asks you that what will be number of electrons, so number of electrons, students, on 1 coulomb of charge, that will be 6.25 into 10 to the power 18 electrons. So that is your amount of, or you can say number of electrons present in 1 coulomb of charge. Next point is, students, the SI unit. If we are defining any physical quantity, we should know the units which will be used to express it as well. So if we talk about electric currents SI unit, so electric currents SI unit is ampere. and this ampere, it will be denoted by capital A. And how can we define 1 ampere of current? It is again very simple. If you know the formula, you can simply get to your answer. See, what is the formula? I is equals to Q by T. Now think about that when we will get 1 ampere as our value. We will get 1 ampere as our value when charge will also have unity value and time will also be of 1 second. So that is how you can form your definition. See how you are going to read it. So when 1 coulomb of charge flows from any conductor in 1 second of time, then we say that 1 ampere of current is flowing. Same is written here as well, that when 1 coulomb of charge flows through any cross-sectional area of conductor in 1 second, then the electric current flowing through it is said to be of how much? It is said to be 1 ampere. So that is how you can remember this particular definition. Definition of 1 ampere of current. Now there are some smaller units as well. There are some bigger units as well. So we have to remember some small units, and those small units are, first one you can see here. First one is milliampere. 1 milliampere, students, if I want to define 1 milliampere, that is equals to 10 to the power minus 3 ampere. Apart from that, microampere, this is another one more smaller unit, and micro, it is represented by sign mu, just it is going to be made like this. Apart from that, A is equals to 10 to the power minus 6 ampere. You can also learn it as what? For now only, you can also say that it is cursive writing U, okay, but it is actually mu, okay. So micro 10 to the power minus 6, milli 10 to the power minus 3 ampere. So these are some unit conversions of smaller units which you should know. Apart from that, next part is, students, flow of electric current in a wire. Now this is again an important topic, that how electric current flows through any wire. So for that, what we are going to take is, an electric current is the flow of electrons, as I have already explained you, in a metal wire or a conductor when a cell or a battery is connected or is attached across its open end. That means, let's suppose that this is what? This is a bulb which we have taken. I am drawing it like this. So let's say that this is what? This is a bulb, and for now it is not glowing. Okay. So basically, when it will start to glow? It will start to glow, students, when I will connect the open ends with what? An external voltage supply. Something which will force electrons to flow from one section to another section. Then only your current will start to flow. So that is the point here. A metal wire has plenty of free electrons. You can see here that we have taken what? We have taken, let's say that this is a metallic wire which we have, and here you can see numerous amount of electrons are present. And all of these electrons, they are moving randomly in all of the directions, right? But when I will connect, let's suppose a battery, this is the wire which I have taken, and I have connected a battery over here. So what will happen, students? In that case, all of the electrons, they will be aligned and they will start to move in one particular direction. And then we will say that yes, electricity is also flowing. So this is how you can understand this. Same point is written. When the metal wire is not connected to a source of electricity like a cell or any of the battery, so what will happen? The electrons present in it moves in randomly all directions, right? They will start to move in all of the random directions. So net flow in this case will become 0, right? Next point, when a source of electricity like a cell or a battery is connected between the open ends of metal wire, so what will happen? As I have told you, there are force acts on the electrons present in the wire. There will be external force which we are applying with the help of cell or a battery, right? Which is helping all of the electrons, which is forcing all of the electrons to move in one particular direction then. So since the electrons are negatively charged, they start moving from where to where? They will start to move from negative end towards the positive end of the battery, right? This is again important part, that in which direction electrons will flow. So electrons, students, they will always flow from negative terminal or negative end towards the positive end. So that is the part here. These electrons constitute the electric current in the wire. And one more part here, that if electrons are flowing from negative towards the positive, then current, it will flow from positive towards the negative. This is very important. Current always flows from where to where? Positive to negative end. And electrons always flows from negative end towards the positive end. That means both of them, they flow in different direction. If one is going in this direction, another one will go in that direction. Okay. So that will be all, students. Let's check that how much we have learned today. So see, this is your concept check number 1. You can see here, what is the unit of electric current? Very simple question, right? We have just learned about this. Volt, no. Watt, no. Ohm, no. So your correct option will be option number C, ampere. Right? Ampere is the SI unit of electric current. So option number C will become correct option. Next question, students, concept check number 2. What is an electric current, or when do we say that electric current is flowing? So here 4 options are there. Heat produced in a wire. If heat is producing, if temperature is increasing, then we will say current is produced. No, that is not the way to define electric current. Flow of electrons in a wire. Yes, we can say that this is the correct one, but we have to check remaining 2 as well. So flow of protons in a wire, no. Movement of sound in a wire, no. So your option number B, that is flow of electrons in a wire, will become correct option. That is option number B. Next question, students, concept check number 3. What happens to free electrons in a metal wire when no battery is attached? That means we are not attaching anything, right? Open ends, there will be open ends in the wire. So they stop moving. They move only in one direction. No, not at all. They will not move in one direction, and they will also not stop moving. They move randomly in all directions. Yes, it can be correct. And they leave the wire. No, this is not going to happen, that they will leave the wire. So according to this, we can see here that our option number C, they move randomly in all of the directions, will become a correct answer. So you can see here option number C is correct one. Next part, electrons move from the dash terminal of the battery to the dash terminal. As I have explained you, let's say that this is positive terminal, right? And there is a wire which we have taken just like this. So my electrons, they will always flow from where to where? From the negative terminal towards the positive terminal. And current, it will flow from, let me mark here, this is electron, and current, they will always flow from where to where? Positive towards the negative terminal, right? So here electrons move from dash terminal. That means here what will come? Negative will come of a battery to the dash terminal. That means here positive will come. That means negative to positive should be our answer. Positive to negative, wrong. Middle to outer, wrong. Outer to inner, wrong. Negative to positive will be our correct option, right? This one. So option number B, that is correct here. So that will be all, students. Let's summarize that what we have learned today. So we started our chapter by learning about sources of electricity. After that, we talked about electric current, flow of electric current in wire. So that will be all for today. Now when we will meet again, we will learn some more new points related to the same chapter. Thank you and have a nice day, everyone.